Lesson 8.5, Division Properties of Exponents. Here's your learning target for today. I can divide powers with the same base. I can raise a quotient to a power. On this page, why don't you press pause and compare what you got on the note sheet that you did in Schoology, and compare and see, make sure you got the right answers. And then you can see how when I wrote it out as what it means, 5 to the 6th power is basically just 5 times 5 times 5 times 5 times 5 times 5. 5 to the 4th power is 4 5s all being multiplied by each other. When you go ahead and cancel, because 5 over 5 is 1, when you multiply by 1 you don't change the product at all. Then what's left is 5 times 5. 5 times 5 is 5 squared. And the shortcut is to just take those exponents and subtract them. But that is only working because, again, our bases are the same. And then that makes our rule for dividing powers with the same base be that you subtract the numerator's exponent minus the denominator's exponent, and you keep your base. And that's how you simplify with dividing powers with the same base. I'm sure you don't want to actually write out a times a times a and do that 6 times and then another 14 times. So instead use that rule which tells us to subtract the exponents, keep the base, and that makes it a to the negative 8th. And then, just like we've already worked with, move that negative exponent to the denominator, and that will make it positive. So it simplifies to 1 over a to the 8th. For m to the negative 1st, m squared over m cubed times n. Again, you can subtract those exponents on the like bases. So m to the negative 1 minus 3 and n to the 2 minus 1. And that equals m to the negative 4th times n to the 1st, and then when we get rid of that negative exponent on the m, our answer is n over m to the 4th. Try the last 3 on your own, press pause, and come back and see how you did. And here are the answers. All of the work has been shown. If you look right here, I'm showing in red how I used keep, change, change, but I still just subtracted the exponents, the numerator exponent minus the denominator exponent. And again, numerator minus denominator for those that have like bases. Raising a quotient to a power is very similar to raising a product to a power. Basically, that exponent n is being distributed to both the numerator and the denominator. So it's a to the n over b to the n. And the same thing here, that 3, exponent of 3 goes to both the numerator and the denominator. 4 cubed is 64, 5 cubed is 125. Just make sure your fraction can't be reduced. And in the next one, 3x squared is squared, so both numerator and denominator are squared. And 3 squared is 9. X squared squared, that's when you multiply the exponents and you get x to the 4th. In the next example, you want to distribute that exponent of 3 to the numerator and the denominator. So it becomes x cubed over y squared, which is then cubed, which can then be simplified using the power to a power rule, where these exponents actually get multiplied. So it's x cubed over y to the 6th. And then in the last one, again, that negative n can be distributed, and that makes it a to the negative n over b to the negative n. To make both of those positive exponents, they basically just switch places. B to the nth is the numerator, a to the nth is the denominator. There is another way that you can kind of work with this one right away to make that n, negative n, exponent to positive. You can just write the reciprocal of a over b, which is b over a. Keep it in parentheses, and that automatically makes the exponent a positive n, which can then be distributed to both the b and the a, and again we get the same result. Try what you learned on the last page for these 4 examples. Press pause, come back and see how you did. And here are the answers. I tried to show each row of work kind of in a new color. So the red is where how I simplified the problem begins, and then the blue is the next step, and then if it required a third step, that was written in black. Hopefully you can look through these and make sense of where I'm getting my final answers from, which are boxed in at the bottom. But obviously if you have questions about any of them, let me know. I will mention that I did use that shortcut that I told you about on the last page, where you could just write the reciprocal of these fractions for the last 2, and then automatically that makes that exponent a positive. And we will actually cover dividing in scientific notation a little bit more next week, but I will tell you that it's very similar to multiplying in that the coefficients, in this case 9 and 36, instead of being multiplied, now it's a division problem, so they get divided, and 9 over 36 is 1/4, which is 0.25. And then that is multiplied by a power of 10, and that power of 10 comes from 10 to the 12th divided by 10 to the -4th, which is 10 to the 12 minus -4. And that is 10 to the positive 16th power. And don't forget, this is not actually in scientific notation yet. If we move it once to the right to make it a number between 1 and 10, then that exponent now becomes 15. So it's 2.5 times 10 to the 15th power. Try the last one on your own. Press pause, come back, and check your answer. And check how you did. The answer for that second one is 4 times 10 to the 19th power.